Welcome to No Diagnostic Required, the companion show to the C++ Annotated newsletter. So I'm Phil Nash, developer advocate at JetBrains, joined by my co-host Anastasia Kazakova. And we're going to be rounding up some of the news from the C++ community in March, but we've managed to get a bit of an off by one error this time, so I'm not quite sure how that happened. What do you make of that?
Yeah, somehow. Maybe the busy season should be blamed.
We have both been very busy just recently getting ready for a couple of releases coming up here at JetBrains, actually. We're going to go back into that a bit later. But before we get to that, have you got any other personal news yourself, Anastasia?
Yeah, actually, some great news here. I was accepted to C++ Now. So I'm going to talk about code analysis. And so this is a very deep investigation I did inside different code analysis tools like Mistra checks, C++ core guidelines, and some data flow analysis and like the patterns, how we use Clang Tidy. So I'm going to gather that all in one talk and discuss all the pros and cons and how they all are related, actually. So what about you? Have you submitted a talk?
Yes. It's an interesting one, actually. It's actually going to be speaking with somebody else. So back in the CPPCon, I did a talk, OO Considered Harmful. Some people complain about the title because when they watched it, I didn't really say that OO was actually harmful. But what I did do was I went into a few aspects of OO, but particularly concentrated on polymorphism. I even went into different forms of polymorphism in different languages. And that seemed to resonate with people a lot. And in fact, I mentioned a type erasure library by Eduardo Madrid during that. And I've actually been talking with Eduardo over the years on and off about this. I've been quite impressed with the progress he's been making. He basically blows away all the other type erasure libraries in terms of performance. And he approached me about doing a dual talk for C++ Now, where I go into those different forms of polymorphism that I discussed in the CPPCon talk. And then he shows how he can do the same thing with his library and sort of see where all the trade-offs are and what turns out best. So it's actually going to be really interesting taking all that very academic stuff and looking at a practical application of it. So I'm quite looking forward to seeing how that goes.
Yeah, that actually sounds cool. I don't think the program is now available, but I think it will be in just a couple of weeks maybe or something like that. So you can check all the talks that are in the program. So yeah, and the conference is for sure online. So, and another online conference which was held recently is ACCU this year. So it was full online. And I guess half of the talks are already available on YouTube and the others are just set the premiere. I guess your talk, Phil, is not yet there. So we're still waiting for the premiere.
Yeah, I think they're releasing them in basically the order that they occurred during the conference. I know it was one of the last talks. So yeah, I'm going to be a couple of weeks away yet.
Oh, yeah. And talking about the conference, what about your C++ and C conference, Phil? Any news?
There might be, yes. In fact, yep, we've announced dates. So going to be end of June, in fact, the 30th of June to the 2nd of July. And we have also opened the call for speakers. So if you have an idea for a talk, now is the time to get it in. It's only going to be open till the 18th of April. It's quite a tight one this year because everything's a bit compressed. So by the time you actually hear this, that may be coming up sooner. It may have even passed, depending on how quickly I get the edit out. So yeah, don't hang about if you've got an idea for a talk. There's a slightly different focus this year, though. Because we have been doing so many online conferences, we decided to do more of a focus on sort of class-based training workshops. So we're going to have 2 days of workshops, including half-day sessions, and then 1 day of the more traditional format of talks and a keynote. We have a closing keynote, but we just announced the keynote speakers as well. 1 keynote, 2 speakers. So Ansel Semmersheim and Barbara Geller. They work really well together. If you've ever seen them do a talk, you'll always know that you come away both informed and entertained. So it's really good. So I'm looking forward to that. And yeah, it's just going to be a bit of a different take this year, I think. Looking forward to it.
Yeah, I think it will be a very educational event in that sense. Yeah, really looking forward to it too.
Yeah, educational is it. And what we did find was that while you can run an online conference and do it well, people are starting to tire of that format overdone a bit too much. Whereas the online training works really well. There are actually some advantages to doing it online. So that's why we wanted to emphasize that a bit. We'll see how that goes. I think.
Yeah, we'll see.
Okay, so looking at some of the news, there's a couple of items you've put in, so I'll let you cover this C++ stories entry.
Yeah, that's actually a very interesting article. So, and it all starts with a question like, how do you usually debug your code? I guess like apart from using the regular debugger, many of us often use just print logging. And like which information do you usually print to the output or to the log? It's usually like, the file and the line and some message. And in order like to inspect these traces properly, you actually add this information about the file and line, and you often use macros actually, to be honest, in C and C++, like file and line macros specifically. And sometimes even wrap them with some, log macros or trace macro as suggested in the article, and hides all these file and line macros inside this trace or log. So in this new article at C++ Stories, Bartek Filipek actually first of all share a few tips for Visual Studio users. So like if you're using Visual Studio and you're printing these debug messages, so if you use the predefined format, which is like file, line in parentheses, colon, and then goes the message, then Visual Studio actually guarantees you an ability to double click on this line in the Visual Studio output window, and you can navigate to the source code, which is a pretty neat feature. And this is really a nice trick. But more interestingly, the article later discussed the way to improve the login approach implementation in general. So like to avoid scanning the variable number of arguments for the trace macro at runtime and move it to the compile time with the help of some C++ 17, like introducing the fold expressions there. The second improvement is actually much greater because it indeed removes the macros, which is nice. But it requires C++ 20 and the newly added std source location, which is there for C++ 20. And the library type actually includes the line, the column, the file name, and the function name, so you can use them. And so you can implement this kind of login using these source locations without the macros. So there are some further improvements in the article discussed later, like using the std format for some, nicer formatting of the messages, and even discussions of the Visual Studio trace points, a very nice feature which it provides. And when I was reading actually the article, I was mostly thinking about the recent videos on debugger we were doing together with UFL, which you recorded on the debugger features in CLion. And I was remembering about the non-suspending breakpoints, which you can actually use to, not to stop the execution, but to log some message or with the file and the line name as well automatically, and add any specific message there. So yeah, there are a couple of tricks in CLion as well related to that. But yeah, overall, do check the article if you would like to learn the modern approach to the logging in debugger.
Yeah, that was one thing that really struck me when I was doing that video you mentioned, was if you use the non-suspending breakpoints with the log feature, you can not only just not have to change the code, but you can put those in without even having to restart the executable. You can already be debugging it and then add it as you go. So that's really great way to do it. I'm glad you also mentioned that there is a tendency towards less macros over time, and I think that's going to be something we'll come back to a bit later today as well. So, okay, there was another article that you wanted to bring out, this Guru of the Week from Herb.
Yeah, I'm a big fan actually of Herb's blog. Many interesting pieces of content there. And Guru of the Week series in the blog focuses actually on contracts. And if you follow it, you may find a lot of interesting information, a lot of interesting stuff. But I want to highlight one particular post published in March as part of this series. So it's like Guru of the Week 101. And the episode 100 actually covers the basics of preconditions. And this 101 is all about the practical examples and some exercises actually with these preconditions. So you're actually given a few functions there, and you have to find the potential issues in the function declarations. So like, what could possibly go wrong? So specifically, the article is inspecting how many ways could a caller of each function get the arguments wrong, so that it actually silently compiles without the error, but something is going wrong. Like, for example, the order of the argument of the same type is wrong, or the value is passed, it's valid, but it's out of range, for example, or it's finally some invalid value passed to a function. So you try to find all these possible issues in the functions you're reading through. And then the next step comes when you try to improve and avoid some of the issues. So first of all, by simply grouping the parameters into separate structure with public variables or using std pair, it definitely eliminates some issues, but not all. Then you try to use the encapsulated class with invariants preserved inside the constructors. So this helps much more than just using a separate structure. And finally, there is a solution with the preconditions. Like contracts, unfortunately, are not in C++20, but we all know, we all have big hopes. So as Herb called it, post C++20. So let's hope for C++23 or something like that. So we'll get them sooner or later. So you can try and think about how you would use them to eliminate the issues. And it's a very interesting also story in the third part of the blog post where Herb is discussing when actually to use each of the solutions. So especially the last two with the encapsulated classes and the preconditions. So, and there are also a set of helpful examples explaining the differences. Like, for example, isSorted is much better as a function precondition, while like not null seems to be better as a type. And no surprise, there is actually GSL not null type there, for example. So there is some sense to introduce it as a separate type, not as a precondition. So yeah, and you can read through these examples and try to think about these concepts, like in terms of these examples. I really a very big fan of these kind of practical articles where you can learn some things on a very basic, I would say, but practical and nice examples. Yeah, so do read it through to learn how to do that.
So one thing to...
Yeah,
oh,
go on.
Sorry, you carry on.
No, I was just wanted to ask, so like, since I was talking about some things which are not in the standard, like, preconditions and contracts, I was wondering what is actually going on there in the committee, because you are there somehow following the news. So maybe where are the contract? Where do we plan to have the contracts? Where are they?
So I do have quite an interest in contracts. In fact, I should take a step back and say I'm a big fan of using correct by construction techniques, which you alluded to a moment ago, using the type system to remove the need to even worry about contracts because it's baked into the type, or at least you move it up to an earlier level. But contracts are definitely very necessary. The trouble is we seem to be having a bit of a trouble pinning down exactly what they are. And that's really why we ended up taking them out of C++20 after voting them in. And I was there for the meeting where we voted them back out, which is a real shame, but I think it was the right decision at the time. It's bought us more time to look into it. So that's a great segue into this month's Sanders News, because the first proposal to talk about is actually it's from Andrzej Kremensky, who, if you saw on the previous slide, he wrote an article that Herb was actually basing his discussion on. And a lot of it comes from this discussion that's been ongoing within the SG21 study group that was set up after contracts were taken out, specifically to move forward that discussion of contracts, make sure everyone's on the same page, rather than everyone just fighting for their own corner, actually bringing everyone together. And a big part of that was just collecting all of the different use cases, both the code examples and the rationale behind it, what you actually want, and also the problems that may actually come out of it. And I think over 200 use cases were actually collected so far, that they may even still be collecting some. And someone went through and had the job of categorizing them all so that you just have some buckets with different categories of examples. And then you've got this great resource where you can say, right, this particular feature, how does it relate to this category, this category, this category? And that's the process that they're going through now. So it's definitely moving forwards. Whether it's on track for 23, I don't know. I haven't been keeping my finger on the pulse quite enough to know whether that's likely at this point, with all the delays with how the pandemic has slowed things down, but definitely things are moving forwards in the right direction. There seems to be a lot more agreement on things. This particular proposal did actually, right at the start, it points out the 3 different ways that the contract violation handler can, what will happen after a violation has been detected. We'll call this handler. And one of 3 things can happen, and this could be configurable. Everybody seems to agree that if it just terminates or aborts, then that's fine. No problem with that. But you may not always want that for different reasons. And it's those second 2 options that have people very divided, because you have the option of throwing an exception. That has problems, particularly with the low-cost rule. I'm not sure we'll get into that, but basically comes down to whether you have no except on functions, whether they're allowed. The bit I want to concentrate more on is the third option, which is if it just returns normally. So it checks the contract, says didn't pass the contract, but then just carries on. It's as if you didn't have the contract there in the first place. Why would you want to do that? Well, imagine you have a large legacy code base that's been running absolutely fine in production, maybe for years, and maybe very valuable. Imagine it's part of a banking system, for example, and it's actually generating billions of dollars in revenue. Well, you don't want that. Don't want to go in, add contracts in, and it just stops working when it was working perfectly fine before. You want to put contracts in to make things better, not worse. So if you put the contracts in and say, look, I want to check the contract, let me know if it fails so I can go off and as a parallel task, fix those bugs, make things a bit better, make sure that some problem that we haven't hit yet, but we might do one day, doesn't actually occur. That's valuable, but still carry on running as it did before. So it's about having that cutoff that's not quite so harsh. And all about detecting the violations, but not necessarily reacting to them. And then you could move to one of the other options when you feel that that's safe to do so. The problem, though, comes when you take into account the optimizer. And this is all about undefined behavior. And everybody loves undefined behavior. And I'm sure we've all heard stories about how undefined behavior can do all these weird things, including travel backwards in time. And there was one really tricky case that was presented in this paper. In fact, I'll show it here. So if you're listening to this in audio and you have a podcast player that can show images, show chapter art, it should be showing up there now. It's worth actually looking at the code. It's a really simple example, but it's using C++ 20 contract syntax as it was before we took it out. We don't have a new syntax just yet. And it's just checking 2 preconditions. Checking that a pointer's not null, and then, obviously, assuming that we pass the first check, then it'll say, well, having dereferenced this pointer, is the value greater than 0? All seems to be fine. Then within the body of the code, it does those same checks again, just in runtime code. You can imagine this might be one of those examples where you're retrofitting the contract. So you already had the check there in the code, and now you're adding it as a contract. So it's an extra level of checks, belts and braces, if you like. This should all be fine. In this case, if it fails the internal check, it throws a stood logic error. This is fine if the contracts terminate or throw the violation handler. It's also fine if the contracts are completely disabled or removed. But in the case that the contracts are checked, but then return normally, this code effectively gets rewritten to this second example I'm now showing, where those contracts are basically written in as just normal code. So it will first check, is the pointer null? If not, it calls our handler, which just returns normally. So it will carry on to the next check, where it now dereferences that pointer. And you can probably see where the problem's coming in now, because now undefined behavior. The compiler can look at that and say, that's undefined behavior, that can never happen. Therefore, I'm going to assume it doesn't happen and take out that check. And that's the thing we often hear about. because it can actually go back and effectively take out the previous check as well. But it can also go forwards and take out that runtime check in the if statement. So now our if statement is weaker than it was before by adding the contract in. That's the really nasty thing about this example that got my attention. So code is now less safe, more UB prone than it was before. And this is why we can't have nice things. So these are the sorts of issues that SG21 are really digging into at the moment. And obviously there are people with strong opinions on both sides still, but they're working through it. So we'll see where this goes, but it's not over yet. Then the next proposal I want to look at, it's not really a proposal, it's more of a notification. So we looked a couple of months ago at a proposal progressing stud colony, which is a new container type that's not in yet, still under development. And one thing I noted at the time was every time I hear about stud colony, I have to remind myself what it actually is. It's quite a straightforward, nice idea. It's a container where you don't particularly care about ordering or placement. You just want to know that once you put something in, it lives in the same place until you take it out. And you can take things out and there could be holes in it. So you can have like long-lived things in there, like game objects, for example, is a good example. You can have pointers to them that never get invalidated. Once you hear all that, you think, oh yeah, colony, that's a good name for it. Well, they've been discussing this in LEWG and decided it's not actually that good a name after all. And in fact, as a metaphor, it works okay in some cases, like a colony of ants or a colony of people. When you get down to things like colonies of bacteria, the metaphor doesn't really hold up. So, this is what the committee really does best, is bike shedding names of things. So of course they've written a paper about this and got into great depth about why it's not such a good name, what possible alternatives there could be, discussing all the pros and cons of those, and finally proposing a new name. And the new name is Stud Hive. Now, interestingly, when I was preparing the slides for this, I was doing a search for colony to see what image would come up, and most of the top images were actually of beehives. So we're already in the right ballpark anyway. So the idea here is that the only real association people have with hives is with beehives, and they do have most of the properties that this container has of things going in and out to these cells. The only downside is that the bees don't actually live in the cells in a hive, but they can sort of brush it under the carpet and live with it. So no name is perfect, but this one they felt was a much stronger name. Interestingly, while I was reading this proposal, it struck me that it feels like that same level of deliberation must have never been applied to the original standard container names, because they all seem to be wrong if you think about it. Like stud vector, it's not really a vector in a mathematical sense. Maps and sets, well, they seem okay, but actually the essential properties of those containers that distinguish them are the fact that they are binary tree based, usually based around a red-black tree. And you have to take that into account when you use them. By contrast, unordered map and unordered set, well, they're different. Yes, they are unordered, and you do have to allow for that. But the real essential property is the fact that they use hashes and hash buckets. And then list, well, it doesn't really convey the fact that it's a doubly linked list specifically. Again, that's the important property. And as you go on, you can find limitations of all of the names. So I come to the conclusion that all of the standard container names are wrong. I've decided I'm going to write a blog post about it, so watch this space. We'll see where we go with that.
I start believing that naming is hard, as Kate Gregory said in her dog. Yeah, and seems that the committee is struggling actually a lot.
Well, they're struggling, but as I say, it's what they do best.
Yeah, that's true.
Talking of interesting naming, this next one I'm going to hand back over to you, because it's based on the talk that Sean Parent did at the ACCU conference just recently, but I think you've seen the previous version, haven't you?
Yeah, so that was a talk, Beta Code Relationships, by Sean Parent. He did that at the recent ACCU held online. Actually, Sean's talk is among those which are not yet available on YouTube. So if you missed that, you will be able to watch it, but a little bit later. And yeah, there were previous versions for this talk done by Sean on like previous events. And one of that was the C++ Russia event, I guess. And that was the place where I've actually watch for it for the first time. But yeah, what I was looking for the Sean's slides actually from his talk, and the image immediately actually captured my attention because of the Russian text on the picture, to be honest. And then I started reading more like carefully from that point. And yeah, that's about the particular picture is about the code check algorithm actually. And yeah, we're again back to the naming, and I think here the naming is kind of nice. So Sean actually called this Russian code check algorithm, and it's an example of coding a case when the program holds some data that's associated with an ID which is monotonically increasing. So yeah, something like a code check, yeah, something like a cloakroom, which is on the picture, and probably that's where the name came from. Maybe he met this cloakroom somewhere in Russia when he was doing this talk previously. I don't know. But I will try to watch the recording of the talk when it's available to find out definitely that's a very interesting fact. But yeah, so I missed the presentation. I went for the slides, but actually I navigated to that slides from the Anthony Williams blog post, where he actually took the idea explained by Sean for this algorithm and actually implemented it. And he provided a link to the GitHub. And the actual algorithm is kind of an interesting example for the Sean's talk, where he explained the idea that relationships between data and the code are important in like many aspects, like performance or memory allocations. And this particular algorithm is just an example of how they could be important and how the actual relationship affects the performance and the memory allocations. So yeah, and Anthony actually implemented the algorithm. The algorithm is, it's like pretty much straightforward. So the map is implemented as a vector of pairs like keys and optional values. And because keys are counted from monotonically increasing index, the vector is like always sorted. So inserts are always at the end, and entries could be simply removed by clearing the data. And if there are too many empty entries, so the vector could be just simply compacted. And again, like since the index is monotonically increasing, the lookups are always fast. You're just using the binary search, and it works nicely. So there is a very short implementation in the article by Anthony, and there is a link to the GitHub where you can find. So yeah, to check the algorithm and definitely wait and check the Sean's talk. Not just because the code check algorithm, but because actually that's a very interesting discussion of these kind of relationships between data and the code and how they affect the whole architecture and like these things like performance and memory estimations. Yeah.
Yeah, I do wonder whether it should be called the Russian Coke colony algorithm.
Hive. Yeah.
Maybe next time.
Yeah, we could ask Sean about the names later.
Okay, moving on to, we mentioned some releases we had coming up. Do you want to talk a little bit about ReSharper C++?
Yeah, this is a very big thing coming in ReSharper C++ 2021.1. So we already posted a huge blog post about that. So I mean, I could actually start here with like the thing everyone knows probably here, that Fels prefers EastConst to WestConst. So yeah, and some users want to use like auto as much as possible, but some want to use them only in the most obvious cases. And there are other like syntax rules and the preferences of that kind. And some code style choices are personal developers' preferences, and some are set by the guidelines like core guidelines, C++ core guidelines, or MISRA guidelines, or any other. Some guidelines could be like general or company or even just, project-wide. And it's often not that important how the particular style is structured, but more importantly, if it's consistent for the entire code base. And here is the place where the tools can help. So they can help you enforce the consistent code style for the whole code base. And that's exactly what we are trying to do in ReSharper C++ 2021.1 version. Actually gathered all our syntax style checks under one settings page, and we added a few new checks, and we plan to add more. So feel free to request more. So what we have for now, so you can configure how to use outer, like never or always or only when the type is evident. Like for sure, there will be still a context action which you can apply to convert an explicit type to outer, but that's more about like which warning do you see in the editor. And like as I mentioned, the east const and west const, so you can choose the camp and follow the rule. The declaration style checks like the type defs versus the type aliases preferences, for example, or like to use the trailing or the regular return type in function declarations. You can also make the choice there. Also, there are settings for using the nested namespaces from C++ 17. Interesting case for overriding function. Actually, we met it in the Unreal Engine coding standard, because C++ core guidelines, they advise that overriding functions should have exactly one of the override and final specifiers and omit the virtual specifier. And Unreal Engine's coding standard, on the other hand, it requires explicit virtual even through overriding functions, always like implicitly virtual. So you can configure actually virtual, override, or both in the settings and enforce the style on your code. There is also style for braces if you want to, for example, remove the redundant braces, or on the contrary, keep them, just to avoid some copy-paste errors later or something. And also styles for include directories and many others. So there's a huge page of settings, maybe some kind of hard effort in the very beginning to configure the style, but later the whole style will be like enforced on your whole code base, and you will be just following this style kind of automatically with the help of the tool. So do check it out. So all the settings are collected under one page, which is kind of called style checks. So, and you can check the blog post for some particular examples and nice animations of how these rules are applied actually. So yeah, this is about the style checks. And actually the whole work is inspired by our more in-depth look into C++ core guidelines and our attempt to understand which of these guidelines are actually toolable and how we can enforce them in the tool, and if we should actually enforce them in the tool. This will be actually one of the points I will be discussing at my talk at C++ Now, because we found out that some guidelines are like not enforceable and some of them look strange as they're, warnings in the tool. But what we've come up for now, it's actually in the syntax style checks. And again, you can like request more from us. So just let us know which actual setting you are missing in the syntax style checks. And yeah, select between the east const and the west const.
So I'm definitely a proponent of east const. It's good to know that I can enforce that automatically now. But also trailing return types is something that I've actually blogged about before. I'm a big fan of those, and I lay out all the reasons in the post. But I even came up with a name for them. I call them East End functions, for reasons that I go into the post. I'll put a link to that in the show notes. You can have a read of that. Yeah, really glad to see that's all made it into this release.
Yeah, naming again.
So talking of releases, there's another big release coming up for CLion, also 2021.1. And we wanted to talk about branch coverage.
Yeah, so actually in the release, there are lots of new goodies and enhancements and fixes, but I would like to focus here on the branch coverage, mostly because it started some interesting investigation in the team to understand how all these types of coverages actually work in different tools. So it started with the branch coverage, which we added recently to CLion 2021.1. So there was some kind of a third-party plugin before that, and thanks to the plugins offer who actually inspired us to add the branch coverage to the main CLion, and thanks to Claire McRae who actually insisted on adding the branch coverage. She requested it for a couple of times, so we finally did that. And when we were adding it to the coverage tool window, which You can see here if you see the screenshot, so or if you just open the linked blog post. So when we were starting adding the branch coverage to the tool window, we realized that we actually have some kind of naming problem, like naming again, and we were trying to understand how to name the appropriate types of coverage. So in general, there are 3 types which are mostly used. There are actually more, but mostly people are using like line coverage, which shows how many lines of your code in % were executed, the statement coverage, which shows how many statements of your code were executed, and the branch coverage, it actually takes into account all the branches of each control structure. And there is an interesting thing here that in CLion, for example, as a backend, we're relying on the GCC GCUF or LVM CUF. So the coverage tool which we use as a backend to actually calculate, to measure the coverage and then present the results in the IDE. So, and GCC GCUF, it actually works in terms of the line coverage. So when compiled with the -- coverage flag, that means that if you have a line like return 0 and then like define some variable C, for example, on one line, you might get a 100% coverage, which sometimes looks strange and you might be surprised by this kind of coverage. And this is not the case for LVM coverage, which calculates statements coverage, so it won't show the 100% coverage in this case. And this was the thing we learned when we added coverage to CLion, and a point of discussion when we were trying to understand how to actually call this first column in the tool window, which we initially called something like statistics, but then let's rename to the line coverage. So it's actually line coverage in case you're using GCC GCUF as a backend, but it's statement coverage if you're using LVM and LVM CUF in a backend. And back to the article and to the third type. So we added branch coverage recently, and it takes into account, as I said, all the branches of each control structure. And for example, like given an if statement, it can tell you if both true and false branches have been executed. An interesting fact that, again, the difference between GCUF and LVM CUF is present. So GCC actually considers the compile generated branches when calculating branch coverage, which is not the case for LVM LCUF. So you still can get different results. And this compiler generated branches is probably more often case for this kind of confusion than, several statements in one line. So each of these type of coverage, I would say they complement each other, and if you're using the separate, just the backend tool on its own, you more or less realize which actual type of coverage you get. But if you're using and relying on the IDE, you'd better understand what is there in the back. So which actual tool you're using in the backend, because it affects the results you're getting in the IDE, which just present, the overall tool window with just the numbers. So, but to interpret them correctly, you'd better understand which actual tool you're using in the backend. So yeah, that's the story about the branch coverage. So there's just one feature from the CLion release. So we'll cover the release news later when the release is out. So you can check all the news in our blog. But if you're interested in the branch coverage, you can check the article linked.
I do TDD training, and I ran one of the examples that I worked through through the branch coverage just to try it out. And it did strike me that, first of all, I should back up and say, usually I would use LLVM, Clang, on my Mac for compiling, and that would give you statement coverage. And what I found was, to get branch coverage to work, I had to switch to GCC because it's only supported in LLVM 12.
Which is not yet released, I guess.
So I switched to GCC, which gave me line coverage, but also those compiler-generated paths, including exception paths. And that showed up much lower coverage because there were lots of exception paths that would never actually be followed most of the time, that were obviously not being tested. So it is something to watch for. It did catch me out when I first saw it. I think that's probably the bigger factor, is the exception paths rather than the statement versus line, but it's worth keeping that in mind as well.
Yeah, that's true.
Okay, finally, we usually like to round up with something a little bit more lighthearted. will we ever get rid of macros in C++? We sort of talked about this a little bit earlier with the line logging stuff, how the trend was towards less macros, but are we ever actually going to get rid of them completely? What do you think?
I'm not sure actually, since I'm now actively working with the game dev world and I'm looking how they do implement many stuff, including the reflection in C++, like on macros in Unreal Engine. I really have little hope, but who knows? Maybe we will. We already have the SD locations, which is a lot because I got used to file and line macros for ages, I think.
Yeah. I've actually written a reflection engine in macros as well, I have to admit. But I've also written a test framework, which is very macro heavy as well.
Yeah, it is.
And I have noticed that over the years, more and more things have gone into the standard where I think, actually, I could replace that now. And source location is an obvious one. That was one thing I thought we might be hanging on for a while, but that's already in. But there's still some things I think that we're going to be stuck with for a while yet. In fact, the Reddit post that I'm showing here, we'll put a link into the show notes for. There's some things thrown into there like token pasting. We may never see a replacement for that. In those rare cases where you do really need it. And of course, I need it in a test framework. But most things we will get there. Certainly by the time we get reflection, there should be very few cases left, I think, where we actually need to write new macros. The trouble is, we'll still have all that legacy code base, particularly those game engines that you mentioned. They're going to be, we're never going to get rid of those. So I don't think they'll ever come out of the language, but hopefully we'll get to a point that most people won't have to ever actually use them in new code, at least. That's my hope. Maybe we will get nice things one day.
Yeah, we'll see. Actually, interesting fact that in Unreal Engine, as far as I remember, these reflection macros, they're actually relying on these file and line macros as well. So maybe we can somehow change it to STD location somewhere in the future. I don't know. We'll see.
Yeah, that I hope is actually a catch internally. Has a class called, I think it's called source file info, which is basically the same thing. The main thing that the standard library feature has that you can't replicate in your own library is the capturing of the values in the first place. You still need to seed it with file and line, whereas with the standard facility that does that for you. So that's the real difference.
Yeah, that's true.
So I think that's a wrap for this month. It's been some interesting news there, and obviously we've not covered everything, but that little sampling. Again, as we've mentioned before, if there's anything you particularly want us to cover next time, do let us know. And otherwise, we'll see you, well, hopefully later this month. So see you then.
Yeah, see you. Bye.